Welcome to Learn Yourself. Today we are going to solve some of the questions from the chapter 3, that is metal and non-metal. Now these questions are from page number 49. The first question, we have to write electron dot structure for sodium, oxygen and magnesium. Now in electron dot structure we are only showing valence electron. We are not showing all the electrons, but only we are showing valence electron which are going to take part in reaction. So for sodium our electronic configuration is 281. So valence electrons are 1. So here we are going to represent with this, that this is sodium's electron dot structure and this will be something like this. Now for oxygen. Oxygen atomic number is 8 and its electronic configuration is 2,6. So here 6 are the valence electron for oxygen. So this is oxygen 1, 2, 3, 4, 5 and 6. This is how we are going to represent electron dot structure for oxygen. Now for magnesium. Magnesium's atomic number is 12. So its electronic configuration is 282. So 2 are the valence electron for magnesium. So when we are writing magnesium, we are showing this 2 electron as valence electron and this will be the electron dot structure or the diagram for magnesium. Now in second question we have to show a formation of Na2O, that is sodium oxide, and then we have to show a magnesium oxide structure by transfer of electrons. We know here that sodium's electronic configuration is 281 whereas oxygen's electronic configuration is 2 and 6. So we require 2 sodium to complete the octet of oxygen. So here this is how we are going to represent. In between we will put oxygen and we are showing 6 electrons of oxygen. Here I am going to represent sodium and here I am showing sodium's 1 electron. To make separate from oxygen's electron, I have marked it with cross. Here this is sodium's electron, this is another sodium. So 2 sodium will react with 1 oxygen. How? They are going to donate this electron to oxygen. So the structure will be like this: Na, then O, then Na. Here it has donated 1 electron, so 2 cross have come here. This will become plus, this will become plus, and along with that oxygen's electrons are already there. So here the oxygen has completed its octet whereas sodium has also completed its octet. So here this will become minus because, and this will become 2 minus because it has accepted 2 electrons from both the sodium. So this is how it is going to be Na2O. So this bond has formed via transfer of electron. And how many electrons have been transferred? 2 electrons have been transferred and both the electrons are from different sodium atom. Now we will see that how can we represent magnesium oxide structure. So here magnesium oxide, and for magnesium what is the electronic configuration? 282, and for oxygen 2 and 6. So here this is magnesium and here it is its valence electron. So 2 valence electron of magnesium, and this is oxygen and these are oxygen's valence electron and those are 6 valence electron. Now in this magnesium has 2 valence electron. So both electrons it will transfer to oxygen and it will lose 2 electron and form electronic configuration like neon. So it will become stable. And while oxygen will accept 2 electrons and form 2,8 electronic configuration like neon. So in a way, when they are making this bond, electrovalent bond, which is formed via transfer of electron, and in this bond both atoms will become stable. So here when magnesium is transferring 2 electrons, we can represent it like this, 2 plus, or you can write plus 2, and here it will become like this. These are 6 electrons which are of oxygen, and these 2 electrons are of magnesium, and here minus 2. In earlier, when we have formed Na2O structure, the sodium's valency was 1. So we require 2 sodium to donate 2 electrons. Here magnesium already has 2 electrons. So alone 1 magnesium can donate 2 electron, and which will suffice the requirement of oxygen. So in turn, with 1 magnesium this bond will possible, whereas we require 2 sodium here to form sodium oxide. So here it will become MgO. So this is magnesium oxide and this is sodium oxide. Welcome to Learn Yourself. Today we are going to solve some of the questions from the chapter number 3, and these questions are from page number 53. Here we are going to write the definition for these 3. First is mineral, second is ore, and third one is gangue. In my explanations video, we have discussed all these 3 thoroughly, and we understood that what these 3 terms are used for. This is from the metallurgy, and why these 3 terms are different from each other. So here we will understand the definition, and the explanations videos link I have given in the description. Mineral, the element or compound which occurs naturally in earth crust, are known as mineral. So any element, we know the periodic table has 108 elements, and from all those elements, any element, or if the element is very reactive, then it will exist in combined state. Then it is in a compound form. When this element or compound which occurs naturally in earth crust, then it is known as mineral. Ore. Some minerals contain high percentage of a particular metal, and the metal can be profitably extracted from it. So there will be so many minerals in the earth crust, but at some geographical area, some minerals are containing very high percentage of any particular metal, which metals when we are extracting, then it is profitable to us by extracting it. That means the extraction process cost we can recover from it, and the surplus charge we can count as profit. So that much amount of metal if present in any earth crust, then it is known as ore of that particular metal. We have discussed that bauxite ore, which is ore of aluminium. So some minerals contain high percentage of a particular metal, and the metal can be profitably extracted from it. These minerals are called ore. Now gangue. When ore are from earth crust, and it usually contaminated with large amount of impurities such as soil, sand, etc. So these impurities are called gangue. So when we are extracting metal from its ore, then we have to separate the metal from its gangue. And what is a gangue? The soil and sand, all those impurities remain present in ore, is known as gangue. Second question is, name 2 metals which are found in nature in free state. When metal will occur in free state in nature, when it has least reactivity, then only they can exist in free state. So all the metals which are placed below the reactivity series like gold, silver, platinum, all these metal can occur naturally or in free state in nature. Third question, name chemical process used for obtaining a metal from its oxide. So from metal oxide we want metal, and for this which step we are performing? So we are performing reduction step, and this process is known as reduction, and with carbon we are reducing metal oxide and we will get metal. In next set of questions, the first question is metal oxides heated with the following metals. So these are the metal oxides and we are heating it with zinc, magnesium and copper. So we have to check whether the displacement reaction will take place or not. So now we have to first see that which metal is reactive and which metal is less reactive. So we know that magnesium is the most reactive, then zinc will come and then copper will come. This is the reactivity of our these three metals. So magnesium can displace zinc and zinc can displace copper. When zinc oxide is there, when we are heating with zinc, so there won't be any reaction because both metals are same. Here when zinc oxide will react with magnesium, so here magnesium is more reactive, so displacement reaction can take place and we will get MgO plus Zn. So magnesium has replaced zinc. Now copper. So copper is less reactive compared to zinc, so reaction is not possible in this case. Now magnesium oxide when react with zinc, so zinc is less reactive compared to magnesium, so zinc cannot displace magnesium, so this reaction cannot take place. Magnesium and magnesium both are same, so here no possibility of reaction. Now copper. Copper is also less reactive compared to magnesium, so this reaction won't be possible. Why any of this reaction won't be possible? Because magnesium is the most reactive metal in these three metals, so it cannot be replaced with zinc and copper. Now copper oxide, it is the least reactive metal, so it will displace by both of this metal. So here zinc, yes, the reaction is possible and we will get zinc oxide plus copper. With magnesium, yes, reaction is possible and we will get magnesium oxide and copper. And with copper, this reaction cannot be possible. So this type of questions we can answer through the activity series of matter. Second question is, which metals do not corrode easily? So metals which are naturally occurring in earth crust, those metals are stable enough, those are noble metals and they will not corrode easily. So what are these metals? Like gold, silver, all these metals will not corrode easily. Third one is, what are the alloys? We know that it is a homogeneous mixture of metals, and why we are making alloys? To make a better metal or to enhance the property of a base metal we are making alloys. In coming videos we are going to solve some of the more questions from the exercise. So don't forget to subscribe, learn yourself. I'll see you in next video. Till then, keep learning, keep sharing.